Finding Riemann integral
That means I think you
and proving some of its basic properties. So, what is to define Riemann integral? Lower Riemann sum of function with partition B being concentrate here would be great. Okay. UFP, and then define that what would be meaning of lower Riemann integral, which was supremum of LFTs and partition P, and define mean by upper integral, which is infimum UFP is the partition of the interval, these are the function is defined, and then he said that f is integrable, and its integral, it makes sense if both of these integrals exist, then they are, and whatever value they will share, that would be the value of the integral. Definitely. We have such a map R, which is bounded, and E is a partition of. That's what we defined last time. And then we proved sum of result. For example, we proved that LFP is always less than or equal to Riemann sum. And that's true in general. In other words, you take any two partitions, general, then also prove that lower Riemann integral from A to B is always going to be less than or equal to the upper Riemann integral of that from A to B. Okay, that's why we did that. And then we ended our discussion at defining Riemann-Stieltjes integral, which is almost analogous actually. So it's like define Riemann-Stieltjes integral, and for that we assume that if alpha is monotonic function and obviously bounded and increasing, then we can define basically some of quantities like LFP alpha. I'm not getting into again that what does it mean actually. Previous discussion on upper Riemann sum, and then using these upper Riemann sum we define integrals BF, not with respect to the double, but with respect to alpha. That's a kind of generalization of integration. And just like if you just take alpha of x equal to x, be monotonic and leading, then
B bar.
B bar.
B bar.
What B bar?
Integral A to B.
The bar is not only so I'm saying that we defined lower Riemann-Stieltjes integral, and we also defined upper Riemann-Stieltjes integral. this bar is not going to be used on entire axis. Okay? And then using these two, we can prove actually that okay, if they both exist and they are equal, then their value is going to be equal to the Riemann-Stieltjes diagonal of F with respect to the alpha. And that's what we defined. And these both properties are also true for in case of Riemann-Stieltjes integral. In other words, if you have lower Riemann sum, you can have almost same results that you prove for the case of Riemann-Stieltjes integral. And similarly, the result of the integral. So from now onwards, I'm going to do what? I'm going to prove all results, for Riemann-Stieltjes integral, and obviously, I'm going to prove for Riemann integrals. So what we are going to cover today is almost all properties of integrals that you know usually, and we take them for granted. So we're going to prove that precisely today that why they are true. So let me begin with proving a sufficient condition. A sufficient condition. Okay, one of the notation of the Rudin is that it denotes R of alpha. So it's like a calligraphic R of calligraphic R of alpha is set of all Riemann-Stieltjes integrable functions f with respect to alpha. Okay? In other words, if I say that this f belongs to R of alpha, calligraphic R of alpha, then this guy f d alpha makes sense, I think. Okay. So it exists, it makes sense. In other words, these two integrals exist and they share their value. That's what the Rudin's notation is. That's a space of all Riemann integrable functions. So I would like to prove what a sufficient condition for Riemann-Stieltjes integrability. Okay. So here's the term. We say that f belongs to S belongs to the space R alpha if and only if. In other words, f is Riemann-Stieltjes integrable. This exists if and only if. For every epsilon positive, I can find a partition P such that the difference between upper Riemann sum and lower Riemann sum can be controlled by this epsilon. Okay? In other words, I can make them closer as much as I want. Okay? That's what we like to do. So here's a quick proof. Pretty much simple. Okay, there isn't anything complicated here. So assume this is true. Okay, assume that this guy exists and is equal to what this upper and lower Riemann integral, and that's what I'm like to prove actually. Okay. So take any partition, P of interval A to B, okay, then this must be true. Right. So, if P alpha is less than or equal to integral of f d alpha. Why this should be true?
Because supremum.
Because this guy is a supremum of all of these LFPs. And I know that this guy is less than or equal to upper Riemann integral, Riemann-Stieltjes integral, the alpha, and this guy is less than or
Sir,
equal
bar on the lever.
to alpha, like the upper Riemann sum with respect to alpha.
So this bar on the integral side.
Huh?
Eva.
Okay. Yeah. But I know that since f is in this space, so therefore the both are equal to what the integral. You should find out.
Say,
Now, here's a trick actually. From this, I can deduce actually, you have to think that why this should be true. That, can I from this actually deduce that the difference between lower Riemann integral and upper Riemann integral must be what?
Yes.
Less than the epsilon.
Yes.
Why this should be the case?
Yes.
So we deduce it.
Bigger than 0.
Sir, bigger than
Okay.
yes, sir, 0.
So we are doing this part. We are assuming this,
yeah,
and we want to show that
belongs
F belongs to R. Why this should be true? That be true? The basis from this is
So, negative on a side.
huh?
Negative on a side.
To be by negative.
It's yes and 0.
So upper से lower से upper. Upper से lower means lower से upper.
हाँ, ये हो गया.
ठीक है.
फिर तो नेगेटिव है. मैं अभी पॉजिटिव.
Positive.
No, negative. You see that why this is
by hypothesis.
why this is how you can reduce it this from this inequality. You want to show precise how you can manipulate it. I want to see that. Okay. Think for a moment and before ending the theorem, give me that. Anyway, so if this is the case, assume that this is true. What does this show? This shows that their difference can be arbitrarily making and made small actually. And hence, this means, it implies that hence both guys agree with each other.
Yes.
That's the alpha. If they agree with each other, that's what means that F is integrable. Ready? Any clue? Alright, so let me get this part. Okay. So there can be lots of ways to do it.
assume anything.
Very,
This is something, but I discovered the difference in the
Otherwise, can we show, honestly, this is going to follow that this is less than or equal to the alpha minus alpha, and that's less than epsilon. So the question is how you can have this inequality. Okay? That's something very elementary. It looks obvious, but give it a try.
अपर का infimum epsilon maybe 0 वो अपर का infimum है
So,
epsilon maybe 0
See, negative. अच्छा, दो inequalities देंगे फिर उनको
सर
that's a good idea. So what we can do is, let's just think about it. Take this as an individual inequality and take this as an individual inequality. So if this is true, then take the negative and, so what will be the negative of this actually? So it's going to be negative and if P alpha is bigger than or equal to this actually. And then add this to this inequality. So you can have one inequality that the integral of f d alpha is less than or equal to b alpha. And the other is that minus of f d alpha is bigger than or less than or equal to minus of L f d. And add them. When you're going to add these inequalities, you're going to have this.
सर
Okay? Anyway. Now, what? Now consider this side. So in other words, we are saying that assume that for every partition there exists epsilon such that the difference between upper sum and assume that f is integrable and we want to prove that inequality is. So let f belongs to integral of f alpha. Okay, so that's why. Right. Good. For that, imagine we have been given epsilon positive. Okay. Show that for this epsilon positive, there exists a partition for which the upper and lower Riemann cells can be controlled by epsilon. Okay. How are we going to do it? Think about this interesting quantity. Like it's a bit differently from Rudin. It's essentially the same argument. Okay, so I get more enough further. Think about this inequality. If I take B at the alpha plus. Nicely, for example, plus epsilon by B. Why this is an interesting quantity? What's going to happen for this quantity? Is there something that we can do?
under different stables. दोनों को डिफरेंस तो एक ही मतलब अपर और लोअर की डिफरेंस तो एक ही मतलब
So इससे क्या मतलब
That my point is that does this quantity give you something? Okay. Well, another hint is that this guy's same is equal to what? Since this is a Riemann-Stieltjes integral, upper and lower sum. So, can you see this?
तो इनका डिफरेंस एप्सिलॉन बाय 2 है
The difference epsilon by 2.
जी सर एफ
Let me write it. A to B over Riemann sum B alpha plus epsilon by 2. Because both will be
सही है
why this is an interesting point. What this guy is,
लोअर
This is lower. This is greater than LFP alpha. Lower sum plus alpha.
but what this guy is,
लोअर
Lower integral.
okay, lower integral, but how you compute it?
सुप्रीमम और
It's a supremum. Okay. The point is that it's a supremum. And you have supremum plus something.
There exists.
supremum or greatest, think about from this perspective. So it's like infimum plus something. So what's going to happen? Okay. This is an important point to realize. So consider this, okay, and treat this as a scratch word action, okay. So I'm saying that consider this guy. So what does this mean? This is supremum of LFP's alpha partition. Okay, be the partition of A comma B. While this guy is infimum of UFP alpha. Okay. P is partition of B. My point is that if I take, and another since this is integrable, so both are equal and it's equal to the integrable. My point is consider this guy, F the alpha minus epsilon by 2. Why this is an interesting quantity? Let's consider the minus first. Come on.
तो इतना एक पार्टीशन बन जाएगी ना.
Exactly, that's what we like to see. Since this is supremum, and you have something smaller than supremum, so this cannot be supremum.
Yeah.
So if there is not supremum, there must be a number in this set which is going to supersede this number. Agony. Okay? And for that number there must be a partition. So essentially we can say that for this there exists a partition P1 such that this guy B the alpha minus epsilon by 2 is smaller than P1 alpha. Agree?
Yes.
Okay. And if I wish, I can remove this.
Because these are equal.
Very well.
Yes, sir.
Okay.
Yes.
I mean, if you see Rudin, he just directly writes this. And he assumes that, people are so smart, they're going to figure out. Okay. You guys are, but obviously, it takes time and sometimes to. Okay, so similarly,
Upper plus some plus epsilon by 2.
so similarly, I would say that there exists a partition to such that
Epsilon
epsilon by 2 again,
upper.
is C and the alpha should be less than. Okay. So plus epsilon by 2
Is greater than.
is bigger than
Bigger than.
UF. Agree?
Similar.
Okay, I can go one step ahead, and from this obviously it follows that if you take the integral of the alpha and subtract LF the1 alpha, this must be less than epsilon by 2. And for this guy, we're going to have
Epsilon by 2 is bigger than.
FB2 minus integral A to B FD alpha, and this is less than 1 by 2
Minus.
F addition. And what we're going to have now
Add.
at the Shall we add that?
Yes.
Okay. Add 1 and 2. But in what sense? You need to, okay, so you need to be careful. Because this is what, with respect to partition P1 and this is with respect to partition P2. So required thing, okay, the inequality that we require involves one partition, not two partitions. Actually. So how you can have basically say for
Subject one is particular.
if one is something of other, or take something of which both are subsets. So take P to be the refinement of P1 and okay. So if this is the case, then consider this guy. UFP minus UFP. Okay? So I know that this guy must be less than or equal to 1.
Epsilon.
No, that's what we need to prove. Can I say that this must be less than or equal to UFP2? The first guy. Why? Because we also proved that if P is contained in P star, then the lower Riemann sum with respect to this partition is going to be the lower Riemann less than or equal to the lower Riemann sum of this. And the upper Riemann sum of this is going to be bigger than or equal to the upper Riemann sum. Okay? So you're going to have this minus LF and 1.
Less than epsilon.
And if this is the case, then I can play around with both. And I can say that this guy is less than what? Okay. Can I say that this guy is less than from this integral minus integral from a to b f d alpha plus epsilon by 2 and minus, are we doing okay? Okay, so it should be plus. Plus. Throw this on the other side. Minus, and this guy is going to be smaller than, so if I throw this on the other side.
By 2 minus.
So, like convince yourself rather than just leaving lines. You're gonna have epsilon
By 2 plus. Minus.
Okay.
Integral
This is going to be integral a to b
of FE as well. Minus epsilon.
f d alpha
Minus epsilon.
minus epsilon by 2. Have this.
Notes का
नहीं है,
होगा इंटीग्रल मैथमेटिक्स
Okay now.
सर कट जाएगा.
just like I get it by 2
Then it's not run by now.
okay
So you're gonna have this actually, and it's the same as. ठीक है.
this is minus का लोअर वहां से फॉलो कर
हाँ follow.
हां सही है
So
directly get you one
you throw this on the other side.
सही plus epsilon by 2 minus
So, and P is basically, since P1 and P2 are arbitrary, so P is arbitrary. Okay? Will making sense with it? So the next thing is that we'd like to discuss is basically that in this class RF R of alpha, in other words, space of all integrable functions there are basically two subclasses. Okay. Those two subclasses are space of continuous functions. Second is space of monotonic function. Monotonic and monotonically. Monotonic function.